Okay, let's go ahead and find out if this input x of t is equated to t cubed is an eigenfunction of this system h is equated to d squared over dt squared. And if it is an eigenfunction, let's go ahead and find the eigenvalue of this eigenfunction. So what I can say is that y of t is equated to h of x of t, which is equated to d squared over dt squared times x of t is this t cubed. So then let me go ahead and do the computation here. I can say then that y of t is equals to d over dt times 3t squared. And if I do another derivative here, I simply get 6t. In order to get it into a point where I have an eigenvalue times this x of t, I can manipulate this 6t to look something like this. So y of t is equated to 6 over t squared times t cubed. Again, as you can see, t cubed is x of t, so this becomes 6 over t squared times x of t. So then that means that in this case, my eigenvalue lambda will be 6 over t squared. But since this eigenvalue is dependent on this variable t, or I could say since this lambda or this eigenvalue is not some complex constant, which again is a e to the j theta, that means that x of t is not an eigenfunction of this system h. This is unlike the previous example I did where x of t was an eigenfunction of this system and it was equated to cosine 2t. And if you want to see this example, please make sure to check it out at my YouTube channel at Professor Gavala. Thank you.